And now we're looking at vulnerabilities. Okay, and this is where we're going to talk about actually enabling the administrator. How many people in this room download untrusted software? Excellent. Smart guys. You go to like hackme.com and say, come take my machine over. Yeah? Now, most people don't install untrusted software, or at least not intentionally. Most people install software from a trusted vendor, right? Even Microsoft is a trusted vendor. You know, you expect Microsoft not to steal your private records and upload it somewhere. Even, you know, Oracle or Adobe, and you know, up till a couple of weeks ago, even Apple you would trust not to do something evil with your data. But, you know, the real hassle in the real concern is not so much the untrusted application, you know, because most people wouldn't install that. It's actually the data. The untrusted data we use all the time. We download data constantly on the machine, and the data triggers errors in the code, right? So it's not IE that's necessarily evil. It's just that there's so many bugs in it that a piece of untrusted data comes into it and triggers a bug that allows the attacker to take over your machine. RHEL is another tool that's constantly getting hacked. There's been traditional TCP dump vulnerabilities from just scanning the network. You could get hit with a vulnerability. OpenOffice, as an example, is probably one of the largest applications on a Linux distribution. It's hundreds of thousands of lines of code. You know there's going to be bugs. Guess what you do with OpenOffice all the time? Download PowerPoint presentations, download doc presentations, right? Off the internet. You're running them. Who knows what they're doing? Lastly, at Red Hat we have a thing called grid jobs. What grid jobs are is it was a product, an open source product called Condor. And Condor is a tool for launching batch scripts. And the idea is that you have hundreds of thousands of computers at your work, that when all the workers go home at night, wouldn't it be cool if those things could come alive and actually run jobs and do something useful for the company at night? So if you had a tool that could make sure that those scripts wouldn't do something evil on your box, you might allow someone to do that. So grid jobs might be a potential if I could figure out a way to prevent them from doing evil. So SELinux might be a candidate for confining these applications, those large applications. But SELinux tends to be tough to write policy for, right? I think of SELinux policy as a programmer's job, not a sysadmin's job. It's too complex for a sysadmin every time he runs an application to have to write policy for it. It's somewhat hard-coded. It does not lend itself to scripting at all. So it's not really a very good tool for allowing a sysadmin to pick and choose what he wants to confine. So in RHEL 6 we introduced a thing called the Sandbox Tool. And the original goal of the Sandbox Tool is we want to block networking, we want to block access to processes. Way processes attack each other is through signals, or if I can write to a file that another process reads, I can attack it. If I can write to the .bashrc script, I can take over a box, as an example. So I want to block access to things like X, you know, the cut buffer in X, things like that. Maybe watching the keys on the keystrokes. Similarly, I want to block access to dbus because I can launch applications with dbus. I can, you know, cause other applications to do stuff. So I can run untrusted applications. So all those people that rose their hands about running untrusted applications, this might be a tool for you. And more importantly, I can run filters on untrusted data. The reason we developed it actually is Apple had an idea. They added a function to their library called Sandbox. And what Sandbox did is it allows file descriptors to be passed into a process, and then the process is not allowed to open anything in the file system. When that happens, people ask me if we could do something similar to that with SELinux, and we came up with a Sandbox. So the Sandbox blocks open calls, it allows all read and write on all inherited or open file descriptors. It allows temporary storage. So if you look at this command, this is sort of the standard Unix pipe command. When you pipe untrusted content to a filter, and then you want the filter to basically only print out your trusted content. So the military does this all the time. They take top secret data, they put it through a filter, and they come out with secret data. You might do lots and lots of scripting languages, scripting tools like this, but if you have the content, you don't know where it came from, and you're just looking for stuff inside of it, wouldn't it be great if it couldn't affect your filter, couldn't cause the filter to do something evil in your system? So by putting it into sandbox mode, this basically says that this filter tool can only read and write past and file descriptors. So the pipe command here actually opens up standard in a filter and passes it standard out from this guy. And the bash script actually with this command will open up a file descriptor to trusted.txt and will pass that open file descriptor into the filter. So instantaneously this works. Now if the filter goes out and tries to open a random place on the disk, tries to write SE shadow even if it's running as root, filtering will be stopped. The sandbox also uses MCS labels, like I explained on the secure virtualization slide, to give us that isolation. So we want to make sure if I'm running two sandboxes, they can't attack each other. It's excellent for scripting. You can do pipes reading, standard piping commands that Unix administrators have been doing for 30 years. It allows you to confine grid jobs. So you can the grid jobs basically usually get handed a file descriptor, read and write, and you can use this to make sure your grid jobs don't do anything evil. So that's a really cool thing for a sysadmin that just writes, standard shell scripting. But what about the desktop? The desktop is the cesspool of communications. Okay? Every app on the desktop needs to talk to every other app on the desktop. They're always interacting, they're always working together. So it's pretty much impossible to confine these guys. All right? Because if I run an application, it needs to write to a dot file. In the Unix system, I counted today, I ran a count. I have 300 and something dot files in my home directory. I have no idea what 97% of those are even for, but there's dot files everywhere. And lots of these apps run in .config and .local and lots of places in the home directory. They have to talk to X. They have to talk to dbus. They have to talk to gconf. Some of them want to talk to the /temp directory. Some of them want to write other places in the home directory. So if I want to confine a desktop application, how do I do it? I pretty much can't. And that's always been the problem with any tools. And the other thing is, if I can find a desktop application, say Firefox, that seems to be the one everybody's dying to confine. If I want to confine Firefox, I usually have to choose a method. And whatever method I choose for confining it, I'll guarantee I'll tick off 90% of the people in this room. So we've never been able to do this until now. We added a -X to the sandbox and instantaneously it worked. No. So we introduced in Sandbox Ex. Sandbox Ex creates and populates a temporary home directory, a temporary temp directory, and then mounts them over the existing one. Everybody's heard of namespacing? This is using namespacing. After it does that, it allows the applications that it's run are going to actually create their own contents in the home directory and temp directory. Luckily, that's the way applications work. The first time you run Firefox, it doesn't expect the .mozilla directory to be there, so we'll create it. SELinux, we use labels to confine the sandbox, put types of labels all over the place, using Sandbox, similar to what we did with the standard sandbox. We also launch another X server. Instead of having one X server, we could have hundreds of them. So this will launch an X server for each sandboxed application. And when it's done, it actually destroys the home directory and the temp directory. Oh, time for a demo.